right, so on this problem, we are finding the amplitude, the period, the horizontal shift of the function, and graphing one complete period. We're going to do a sine curve here. We're going to label our increments on the graph for full credit and extend the graph as needed. So remember that when we're looking at this, our y is equal to a times our sine of k times x minus b. And what all these parts are. So A is our amplitude. This is going to be our K, which is what we'll use when we're finding our period. And the B is going to be the horizontal shift. So when we're looking to find the amplitude, looking at our problem, that's going to be the A. So our amplitude is equal to 2. Our period for sine and cosine is going to be 2 pi over K. So in this case, it's going to be our K is going to be equal to 1. So that's 2 pi over 1, which is 2 pi. And our horizontal shift is the B that's right here. Now you always have to make sure that you just have a 1x, otherwise you have to factor out. But we're just looking at 1, so we're just going to look right at our horizontal shift there. So that's going to be pi over 2. It's always going to look opposite of what you see because our formula uses the negative. It's going to be pi over 2, and we're going to go to the right. If it was positive pi over 2, then it would be negative pi over 2, and we would go to the left. So a lot of times when we do these curves, we want to start out by graphing the first one. You don't have to, but many of my students find that graphing the initial sine curve, just a regular sine curve, kind of helps them. I'm going to use 4 values over to go to pi and do another 4 to get to 2 pi. I'm doing this light because I want to just be able to look at a basic curve and then adjust it. So then we know about halfway between 0 and pi, our sine curve, this is off our unit circle, is going to hit the value of positive 1. It's at 0 starting out. It's at 0 at pi and 0 at 2 pi. That's where the values are on our unit circle for sine at those spots. And then when we get, this would be pi over 2. And this would be 3 pi over 2. At 3 pi over 2, we know on our regular sine curve, we're hitting at negative 1. So we know that it's going to come up this way, come down, and I'm just kind of sketching it in so we have just a general graph of it. I know it's not very dark, but I'm purposely trying not to do it too dark because that's not the actual graph we're looking for. So now what we want to do is graph where we're at. We know we're shifting over pi over 2, so let's figure out where we're going to start. We know we're going to start at pi over 2, and we know that we're going to end at pi over 2 plus 2 pi. If we do a common denominator, we know that this is equal to pi over 2 plus 4 pi over 2, which will get us 5 pi over 2. And that's, we can see pi over 2 is landing 2 dots because that's the increments we chose. So I know it's going to end here at 5 pi over 2. And then if we want to find our middle spot, we'll take and look at this. We can look at this very simply. Normally we would land at pi. If we take pi over 2 and add pi to it, that would be the same thing as pi over 2 plus 2 pi over 2, because that's 1 pi. It'll get us 3 pi over 2. So we're still going to be using that 3 pi over 2, but we're actually going to be intercepting at that point. You can also look at the fact, and I'm going to make that a little bit darker so you can see, we are looking at, if it's at 5 pi and 1 pi and 5 pi, the middle of that is going to be a 3 pi over 2. So these are the increments we're looking for to label on our graph to know. We know we're going to start here, we're going to come up, cross here, come down, just like it did on the regular curve. But our amplitude is 2. So this was an amplitude of 1. We're choosing an amplitude of 2 at that spot. So we know we're going to start here, and at halfway in between, just like we did before, we're going to come up and hit 2. We'll cross back down, and then this means this is going to be negative 2. And halfway in between our 3 pi over 2 and our 5 pi over 2, we're going to hit that negative 2. So it's going to cruise up and then cruise down and curve back up. And as long as you're pretty close, you're good to go. So this would be the curve graph, one complete period. I don't want to see the entire thing that your calculator does. I want to know that you know what one period is. Make sure you're labeling your endpoints so I know that you know where it starts and ends, and answer your 3 parts.